Good afternoon. My name is Khursevich Alexey. I represent the company QA. The topic of my presentation literally translates as "through hardship to excellent solutions for test ops."
наоборот, через терник к хорошим решениям в контексте тест-опса.
Just for understanding who today's audience is, how many of you are involved in test automation? And in DevOps or environment setting, I think the material presented today would be useful for you anyways.
Вам всем будет более-менее полезен материал, который я здесь предоставлю.
A few words about myself. I have about 8+ years experience in test automation, development, and DevOps. The founder of the company QA. I was an automation engineer and then a developer for quite some time. I am an active contributor to a few open source projects, about which I will talk a bit later. At the present time, I am involved in R&D and DevOps solutions. Among the topics I would address today, the first part of my presentation would be more on the theoretical side, and the end of my speech I will address real case studies which you could integrate into your DevOps or TestOps. So first of all, I would like to talk about the most valuable things you need in production, what is important to the customer, what makes our results more visible and more valuable. I'll address the topic of the open source tools that we use. Maybe some of you are already familiar with them. They're just recommendations in case you're looking for solutions. I'll provide a list of what we use. At the end of my speech, I will share a real-life case study, how we set up live streaming and video recording for mobile and web tests with the help of such tool as Selenoid. I think some of you may already have used Selenoid, right? For mobile tests, we use APM. First of all, the customer expects to have a cross-platform solution. Today, most of our customers have different clients, both mobile and web, REST API, and in some cases, they need an automation for gaming consoles. If someone's interested, after I finish my speech, I'll share how we did it with the help of computer vision and AI. We thought it would be great to have a toolset or a framework that would help us to make our tests truly integrational, to call REST API to continue mobile or Webflow. You get what I mean. Concerning test maintainability, I think you should stick to the main practices and good projecting patterns based on the object-oriented programming. The last trend is functional testing using page objects. From the proof of concept point of view, it may be right, but from the experience in real production, those tests are impossible to maintain. So I highly recommend using an abstraction of UI level for mobile automation when iOS and Android clients are quite alike. And the abstraction of this layer with the corresponding iOS and Android implementation lets you reuse a huge amount of source code without making drastic changes in it. Use page objects and UI components as much as you can to have the clear structure of your test, to transfer the main business logic and locators onto page objects. Using UI components, some basic elements like navigation menu, various controls that are present on the pages or screenshots of the app, they should be gathered into separate classes and separate UI objects. I'm sure every one of you is familiar with the data-driven testing. To implement this approach, we need another approach with data parameterization with the use of data sources. parameterize text from Excel, from databases, make a possibility to reuse the same source code on different datasets. You get a large amount of tests, given opportunity to check different domain areas of the product you test. Combine REST API calls with the UI validations. Make tests more fast and more stable. Concerning visibility, some teams practice an approach when automation stands away from development and manual QA. Automation engineers get certain tasks, they automate a number of test cases, run them, control the results, do bug fixing themselves, and so on. It works not really well. My opinion is that you need much more visibility in the process. First of all, it's giving the management what they want. Boring tables representing the amounts of failed or passed tests, random stack traces tell them nothing. I recommend using our tools in terms of emailable reports on a daily basis and various types of visualization like graphs and tables that are clear to the management. Try to gain loyalty from your development team. Explain what your automated tests do, how to integrate the test running process into your CI. Make small test suites running for 5 to 7 minutes or even faster. If it's a REST test, for example, if it's UI integration test, they may take a little longer to run. Give them an opportunity to understand and get those results as fast as possible. Developers would enjoy this approach, and it will lead to establishing a loyal relationship between them and a QA automation department. Manual QA engineers themselves are able and ready to understand test automation results. Give them a tool to check test results like artifacts, logs, or screenshots, and an opportunity to interact with the stuff, because you know yourselves that tests fail due to the weak performance of a test environment or infrastructure issues with Selenium, Appium, for example. 5 to 10% of tests may fail, and if you're going to manually check every test run, you'll spend too much time in maintenance. Those tasks can be curated by your manual QA engineers. All those parameters, visualization, emailable reports, let your QA management to better track your velocity, the exact amount of tasks you are able to complete for a certain period of time. So further tasks would be more adequate, and you would manage to complete them in time. Concerning the integration into CI process, you should let your test automation be triggered on commit basis or pull request basis, have the opportunity to start test manually or on a regular basis by the means of schedulers like nightly regression or release regression and so on. I think you already use it. Organize tests in an intellectual way, not only by the amount of tests like minimal acceptance, acceptance, regression. Let there be opportunity to test features. Form test suites containing tests on profile management or user management, so in case when developers are doing bug fixing or writing new functionality, they can run a certain amount of tests and don't have to wait long when regression or acceptance tests are running. Allow the possibility to run tests with flexible configurations, an option to choose an environment, a browser or a mobile device on which a test should be run. In our products, we have implemented a feature called Smart Rerun. I guess many of you have experienced a situation when, during the regression, 5 or 10% of tests fail, and you realized that it was due to the Selenium issues. For example, 50 tests out of 300 failed, and there is no use in rerunning the whole regression. In our products, we've built a logic allowing you to rerun only failed tests or their sequences and to aggregate reports from two separate runs. Concerning open source solutions we use, I think many of you know them and use them. If someone's still searching for a solution, consider them as an option. From our point of view, they're the most suitable ones for solving a wide range of tasks. It's clear that we use Selenium for our web automation and Appium for mobile automation. For the test lifecycle control, we use TestNG. In our opinion, it's more flexible compared to JUnit. It allows to group test to set TestNG XMLs. We also use Maven Surefire plugin, which allows to run certain groups of tests under CI, to parameterize them, and to get the corresponding artifacts in the end. For real-time or historical reporting, we use RabbitMQ and Elasticstack for archiving those logs and searching through the archives. The rest of my speech would be dedicated to this topic. Concerning test execution environment. If somebody is not familiar with Selenoid, I highly recommend reading about it. I'll give the links at the end of my speech. In brief, it's a new generation of Selenium Hub, allowing to run every testing session in a Dockerized environment and in a separate Docker container, be it web tests on the most popular browsers like Chrome or Firefox, or mobile tests. The previous speaker, Ivan Krutov, told how to run Android tests on Selenoid. Our mobile automation is currently being run in a mobile cloud. It's our own internal project, a real device farm held in storages in our office. They're connected to a server through hubs. The farm is used by both manual and automation QA engineers. Maybe some of you have attended the previous Daleks conference. I was talking about the Dockerization of a real mobile device farm. An OpenSTF, you should Google it, an excellent open source tool allowing you to control the aggregation of the outside devices. Through the web interface, you can interact with devices like you would in BrowserStack or Sauce Labs or Perfecto Mobile. The interaction is now possible on Android, and we're currently working on the adaptation for iOS devices. You interact through the web browser. You can swipe, type, click, install apps, and so on. For orchestration of the infrastructure components, we use Ansible. With the help of pre-made playbooks in YAML format, it allows us to deploy and install packages through SSH, to administer the access rights, to create files, configurations, and so on. Ansible allows to do the above-mentioned things automatically and not to spend too much time on it. Our whole testing infrastructure, be it Selenium Grid or Appium Grid, is built in a Dockerized environment. This means we use Docker containers, and we're planning to move from the physical service, which we have in our office, onto the cloud platforms like Amazon or Google Cloud, and to administer the whole infrastructure by the means of Kubernetes. We use Jenkins as a CI tool ubiquitously. It's the most suitable open-source CI/CD tool. With the help of pipelines, we arrange test runs after a dev build and set up various configurations. Specifically on products, don't be lazy and check out our GitHub page to see what tools we have. They're all what we have aggregated during the last 8 years. We've analyzed all of the customers and our issues and made pretty good solutions, which we use for our customers, be it web, mobile, or REST automation, all the things I've mentioned before.
использованы, которые сейчас повсеместно применяем с нашими клиентами, будь то для веб-автоматизации, мобильной автоматизации, REST, всего того, о чем я уже говорил.
Zafira is our Java-based web application composed by using the Spring framework. It's used for aggregation of all the test results from Karina with the help of realized Zafira listener agent. All the test results are published in a web interface where you see all the graphs and test results. You can interact with the dashboard, report known issues, see what's happening with the test in real time with the help of VNC session, get video recording. mCloud is our product, mobile farm for the test automation and manual interaction. QPS Infra is also an open source product which allows to deploy testing infrastructure just in minutes. It's a set of Docker Compose files and configurations which allow to deploy enterprise-based automation infrastructure. Here's a high-level scheme. In the center there is a CI/CD automated test runs, which we write with the help of Karina. We run tests on web and mobile and sometimes even on connected devices. We test REST APIs, and all the artifacts and results are published in Zafira. Through Zafira, we provide graphs and email various types of statistics. We see screenshots, logs, and video recordings. Now we're moving to the technical part of my speech. Let's see how it all works. This scheme is the same if you use your own tools for writing automation scripts and a reporting tool for visualization. So you can replicate this approach. It's a working concept which we've checked ourselves. Concerning real-time reporting, you have a test running, click some buttons, types text. You want to see what's happening with it in real time with the help of a web interface or something like that. In this case, we use Zafira Log Appender, an implementation of a Log4j appender, which publishes every event coming in Logger in RabbitMQ Exchange. In its turn, Zafira also connects to this Logger Exchange, and you can see all the changes in real time. A test pushes the button. This information appears in Zafira. A test goes to a new URL. It appears in the web reporting tool. Concerning historical items, who have heard about ELK, Elastic Stack? Raise your hands. What components are there in the stack? Right, and Elasticsearch. In this case, we use one or two components. We actually don't need the visualization through the Kibana. We do this with the help of our reporting tool. The goal was to set up the Logstash and the Elasticsearch. How does it work? When there is a need to look through the task logs after a certain period of time, we set up a pipeline in Logstash, which receives an input exchange from RabbitMQ. The data in the exchange with a corresponding correlation ID, it would be test run ID and test ID. It records all the data into the Elasticsearch. And when you log into Zafira Web UI, when a week, a day, or an hour passes, you get the context of what you need, test ID or test run ID. You look into the Elasticsearch, form an HTTP request, and get the amount of data you need, all the logs. Configuration is really simple. In Logstash, you need to form custom Logstash file and configure the pipeline. Pipeline has an input, the point you count from. On the left, you can see the configuration for RabbitMQ, host, port, username, and password. And output, in this case with the help of Logstash, we write into the Elasticsearch. Since we're using this ELK stack in the Docker context, there's a collected image that we use. In this case, host Elasticsearch is also a local host for Logstash, and ES and LS are in the same container.
одного контейнера.
Here are some moments you should bear in mind. Since you enter the Elasticsearch not through Kibana, which is placed in the container, but through the external REST client, our Zafira, in this case, you need to additionally adjust the cross-origin request policy through the Elasticsearch YAML.
В этом случае нужно через Elasticsearch YAML настроить дополнительно политику cross-origin запросов. То есть в данном случае одним из важных параметров является указание.
One of the key parameters in this case is that we let HTTP course enabled true. Here you can list the hosts which generate requests, or you can put a star and send requests that do not depend on the origin host.
Вы можете поставить звезду и делать запросы вне зависимости от хоста origin.
Now a few words about video streaming. If someone has worked with Selenoid, you know it has two great plugins, Enable VNC and Enable Video. Enable VNC lets you run a special container which opens a standard or a predefined port, and through any browser or VNC client you can connect to a host port and receive a real-time testing session, and moreover, to interact with it through the VNC session if something goes wrong with the test and you want to double-check it.
И более того, через VNC-сессию взаимодействовать, если вдруг что-то там пошло не так с вашим тестом, вы хотите допроверить. Соответственно, как это выглядит?
So this is how it works. You use a testing framework or Karina itself. Through the desired capabilities, you write enable VNC equals true. This command runs a recube Selenoid container with a VNC support and lets you see what's going on in a test session. Unfortunately, by default, Selenoid doesn't support addressing the session via secure WebSocket protocol. In this production, we want it to be secure both at HTTP level and WebSocket level. It won't work another way. If HTTP is used for a web service, there would be a browser alert. The interaction should be held through a secured protocol with pre-installed certificates.
Иначе у вас не получится, если HTTPS используется для веб-сервиса, то, соответственно, сам браузер будет ругаться, что вам нужно общаться с веб-сокетом тоже по секьюренному протоколу с установленными сертификатами.
In this case, Zafira, or your test automation reporting tool, interacts with Nginx through a secure protocol, and Nginx is proxying the traffic into your environment through the unsecured WebSocket. We use a remote frame buffer protocol as a client. At the end of my speech, I'll provide the link for a Java-based Node VNC client, which would help to connect with the corresponding VNC session via browser. I'll say a few words about this config. If someone has already used Selenoid, you've probably heard about GoGrid Router. It's a hub which aggregates several Selenoid instances. If you run a huge amount of tests, it won't be possible to run them on a single machine. So if you use Amazon or a local infrastructure consisting of several servers, there's an entering point which distributes requests among the nodes. In this GoGrid Router quota, you should additionally see the VNC parameters. It gives instruction to GoGrid Router to proxy this traffic from the entering VNC point to a specific node in Selenoid. It's really important. This information would be available and posted somewhere after the speech, so you can copy-paste this configuration of Nginx, which lets us, through a secured socket via the VSS protocol, to access hostname/VNC and to proxy pass the traffic through VSS to GoGrid Router, which uses unsecured protocol. A few words about VNC streaming for mobile devices. For our mobile automation, we use our own build of a Docker container, which has everything needed for running APM tests. On this picture, you can see that when a real mobile device interacts with the server, it runs a corresponding container, which has ADB consisting of Java, Appium, and STF.
Имеет на борту ADB, который имеет в себе там Java, Appium и STF. Вот STF провайдер это
STF is a visualization service which lets you interact with mobile devices through a web interface.
взаимодействовать с мобильными устройствами. Так в этом
It turned out that the STF has an ability to connect to your real mobile device. Unfortunately, it uses a TCP protocol, so you have to additionally install WebSockify, which would let you to proxy pass the traffic from a WebSocket type to a TCP type.
WebSockify, который позволяет вам проксировать трафик, получается, из веб-сокетного в TCP-шный.
So what happens next? Just like with Selenoid, we let it perform the inventory of the test through the plug enable VNC equals true, which starts WebSockify proxy. We still have our traffic running through an unsecured protocol. We proxy pass the output through Nginx and run it through VSS.
Наружу мы его проксируя через Nginx уже запускаем по VSS. И по привычной схеме через RFB клиент
According to the scheme, through an RFB client, we connect to an URL and get the real-time information what's going on the tested mobile device.
мобильном устройстве.
Now a bit about video reporting. All the logs are available both in real time and in historical format. Concerning video, a connected VNC session is in real time, but it happens that you analyze the test later in perspective.
Тесты, ну, какой-то, собственно, перспективе.
You want to analyze 5 or 6 failed tests and see the video recording of what happened. All the enterprise platforms like BrowserStack, for example, they record the video, so you can see what was happening and why the tests have failed.
Видео, и в целом у вас как бы нет претензий, вы видите, что происходит, и можете проанализировать, почему тест упал.
Selenoid has a standard desired capability called Enable Video. It means that Selenoid runs an additional container which proxy passes the whole VNC traffic and records a video in an MP4 format.
И записывает в MP4 формате.
If someone has worked with Docker, you have to set Nginx and Selenoid up in such a way that they have the volume in the same folder, so the recorded video is accessible through the web from the outside.
То есть, чтобы записанное видео с Selenoid, оно было доступно через ваш веб-сервер где-то снаружи.
We set up Nginx in such a way that when you address hostname/videos, the video name points to a specific folder where the Selenoid puts it.
Видео, оно смотрело в определенный фолдер, куда пишет сам, собственно, Selenoid. То есть
You know the session ID, since your automated test initialized the WebDriver, and with the help of session ID, you can find a correlation between the recorded session and the test itself for which the session was recorded.
эту сессию записывал.
This is the configuration. For Selenoid, we need to override a variable video output. I think it's stated by default in the Selenoid documentation.
Я думаю, что это в документации Selenoid уже по умолчанию написано.
Secondly, everything that is placed in the container opt Selenoid video should be transferred to a host machine. Current directory /Selenoid/video.
Selenoid/video.
Concerning setting up of Nginx in a Docker Compose, we also state that the volume in Selenoid video is shared onto internal user/share/Nginx/video. The Nginx content itself presupposes that you would statically address by the means of /video the resources which are placed in the corresponding folder.
Соответствующем фолдере.
Long story short, things are pretty much the same here, hence Appium 1.8.0 and newer versions possess a nice new functionality which is poorly described in the documentation. I found this information on the release notes and used it for good.
Я нашел эту информацию и
1.8.0 version lets us choose the desired capabilities, which let us record the real application testing session both on a real mobile device or emulator.
сессию, получается, тестируемое приложение на мобильном, на реальном устройстве, либо эмуляторе, неважно.
You need to set only a few parameters that instruct Appium to start recording. There are settings for a video recording session like video resolution or bitrate, and you also provide credentials for your FTP server. By default, when recording stops, the video itself is being placed in the FTP server. Here's how the picture looks. As soon as we command APM to stop recording, it uses the before given credentials to push the video on the FTP server. FTP server is set up based on a public Docker image, a huge amount of which is available. This process is described in the infrastructure documentation. APM pushes FTP and the scheme is quite alike to the web one. Nginx and FTP also point to the same folder, so you can use the regular scheme host/video/session-id/mp4 to gain access to the recorded video through your reporting tool. You know your session ID, so you address it and get the information about what was happening during this particular test run. To prove my words, I would play a short 30 or 40-second video showing how it looks like in real time. This is the interface of our tool called Zafira. There are tests running in progress. I'll open the web test just for an example. Here are the events from RabbitMQ displayed. Here's the real-time session streaming from a browser. We can see URL being opened up and interacted with. Moreover, you can click on the screen and interact with this web screen. Here's a mobile test running at the same time. We open the visualization of the test, see all the logs being pushed through RabbitMQ, and you see a real mobile device with an actual application being tested on it, with a mobile test interacting with an app. I'm going back to the main screen and open a web run. I'm showing you that in a failed test there is a video recording with subtitles to show what happened or what actions were performed by the automation during a certain moment in time. This also applies to mobile tests as well. That's pretty much it. Thank you all for your attention. Here is the list of the main open source tools: Karina, Zafira, and QPS Infra. Selenoid for you to try. It's a really nice tool. VNC, a Java-based RFB client which allows to connect to socket through the web page where the frame streaming is happening and see what's going on within a tested app. And the closing line. If you don't want to dive that deep, but you want to set up artifacts for debugging, go to APM's GitHub. There's a Java test which starts and stops screen recording. In the end, you get a MP4 video of the test run. Any questions? Good question, thank you. Concerning the smart rerun logic, there's an integration between our test automation framework, Karina, and Zafira, our database with test results stored in. After every test run, we go through the whole test scope and flag those tests which need to be rerun. Of course, the first ones to be rerun are skipped or failed ones. But there are cases when you have chains of dependencies, and if one test in a chain fails, you have to rerun the whole chain. The logic flags only those chains which need to be rerun. Concerning periodically appearing bugs, this feature is called known issues. When an automation or manual QA engineer notices a broken feature which cannot be fixed by developers anytime soon, we mark the test as a known issue, attach Jira ticket to it, and our reporting tool calculates a hash code. We have a stack trace. We clear it from the necessary data like digitals, Selenium errors generating universal UDIDs, and so on. After we get rid of this data, we calculate a hash code, put it in a database, and further, if we run into a stack trace which has the existing hash code, we mark the test as a known issue, and maybe it will not be needed a rerun in the future. So when we have a list of marked lags from the previous reruns, test fails, we need to rerun them. Test marked as a known issue, there is no need to rerun it, the same with dependency chains. During the next rerun, we state a CI run ID, which refers to a previous one, and based on a test.ng listener, with the understanding which tests and why are marked, we skip the test as I already passed one or rerun it. We track results in the same test run. Our Jenkins is Dockerized. Yes, your question, please. Sure. Before starting a rerun, with the help of our tool's functionality, we analyze the scope of tests for the day, let's say, or the whole amount of tests running. The tool analyzes the error, and the most frequently occurring ones are placed higher in the table. It may be an issue with Selenium crashing, and this error should be handpicked out of all the other errors. So before doing a smart rerun, we analyze the priorities table. If we figure out that there is a production-based bug among the most frequently occurring ones or the whole bunch, we have to fix it in the first place. Then we make a decision to mark this test as a known issue and we won't rerun it further. For the first time, known issues are marked manually if there is a stack trace. Further, the system recognizes the hash code and sees it as a known issue.